All right, let's start talking about this guy. First thing I need to do before I can do part A or B is figure out what formula I need to use on this one. Yes, ma'am.
A equals P parentheses 1 plus R over N equals N times 7.
Absolutely. A equals P, and then inside parentheses 1 plus R over N. Close your parentheses to the power of N multiplied to T. We're going to use that form for both parts A and B. Which letter up here would I use for the deposit amount?
7,000.
Which one? 7,000 is what I'm going to put in, but it's going to go in the place of which letter? P. P is always our starting or our initial amount. So you deposit 7,000. That's going to go in for P. I don't care whether I'm doing part A or part B. That goes in for P because we were told that at the beginning. All right, so I know I have equals 7,000. What do I do with this 9%? Yes, we're going to divide it by 100, and then we're going to put it in the place of R. Again, for both parts. So divide it by 100. So my R value is 0.09. That 1 always stays a 1. Plus always stays a plus. And now we've got our rate, 0.09. What do I do with this monthly piece of information? We put 12 in for N. Why? Yes. 12 months in a year. It's always how many in a year, because when we're talking about investments, people measure time in years. Because normally you don't invest something for just a couple of days or a couple of weeks or even just a couple of months. If you're going to put it in an investment vehicle, you're going to leave it there for a long time. So we measure that in years. 12 months in a year. And so N is equal to 12. So that's going to go down here. Does N go anywhere else? Yes. It becomes part of our exponent as well. N shows up in both spots. Whenever you have a variable show up more than one place in an equation, it's the same value if you're substituting in. Can I use any other information that they gave me up here in this bold text before we get down to part A? No, we've used everything they've given us. We used the 7,000, we used the 9%, we used the monthly. How much money? What are they wanting me to find when it says, how much money? A. We're looking for some future amount. And that's what our A represents, is a future amount of money. How much money will you have in 10 years? What do I do with this? Put that in for T. So we're going to multiply that to the 12. If you want to, you can simplify that. What's 12 times 10? 120, because that would be easier to put into your calculator all as one step. At this point, because one side of my equal sign only has numbers and operations, buttons that I have on my calculator, I can grab my calculator and I can just type this right in. I know it's coming out as money. Since I started off with $7,000, am I going to need a comma in this answer? Like, is it going to be a pretty decently large number? Yeah. What's it start with? What 2 digits does it start with? 17. And then I need a comma after that, and there's 3 more numbers before I get to my decimal point. 159. And because we're talking about money, after I put down the decimal point, how many more numbers do I want? 2. What are those 2 numbers? 49, or you could round it up to 50, because it's like 0.499, right? It's almost 50 cents. Am I going to count it wrong if you put 49 cents instead of 50 cents? You're not going to miss the problem over a penny. That's ridiculous. My preference is that you would round it up to 50 cents, but if you leave it as 49 cents, I'm not going to count it wrong. Do you guys have any questions for me on part A? Part B uses the same formula, and everything that came out of that bold text at the top, I'm going to use again. So what pieces am I using again on part B? 7,000 goes in the same spot because that's still my starting amount of money. What else am I reusing? 0.09, that rate. What else? 12, because it's still being compounded monthly. It's still the same bank account. What do we want to know in part B? How long will it take to increase your money by 50%? So let's just start with the question words here. How long? If somebody asks you how long, what do they want to know? Time. If that's the thing we're finding, then we need to still have a variable there. So I'm going to leave that as a t. I'm missing something. A. Since I'm looking for t, I have to have something to put in for a. Math is really good at finding stuff, but only one thing at a time. So if you have more than one letter left, you're stuck in the water. It says, how long does it take to increase your money by 50%? Increase means to do what? Go up. We started off with 7,000, right? And it's going to increase, go up, by 50%. Give me another way to think about 50%. 50% is how much of something? Half. So I want it to go up by half. Well, we started with 7,000, right? What is half of 7,000?
3,500.
3,500. So I want 3,500 to be my final amount. Keon's saying no. What do I want my final amount to be? 10,500. How did we get to 10,500? That's correct, by the way. Yes, I want it to go up by this much, but I still get my starting amount of money. They don't take that away from me. So 10,500. This is our future amount, our A value. So I'm going to put that on the other side of the equal sign. 10,500. Remind me what our goal is again. We want to find t. We want to figure out how much time it's going to take. Where is t? It's part of my exponent. T is up here. Since it's part of an exponent, it's on a base. 12t is an exponent on what? Yeah. 1 plus 0.09 over 12. This whole set of parentheses is my base, and I need to isolate that so that I can move forward. So the parentheses stay, since that's the base. The exponents are stuck onto it. What else is on that side that's not the parentheses or the power? 7,000. So we're going to divide it. You're absolutely correct. We're going to divide both sides by 7,000. What is 10,500 divided by 7,000? 1.5 is equal to, and then I've got my parentheses with the 1 plus all this jazz. Have I isolated my base? Yes. The only thing that I have left on this side is the parentheses with the power stuck onto it. So it is isolated now. I like that. I still need to get the exponent by itself. Normally, this is where we would draw our triangle. However, yesterday I didn't do that because I don't have a button on my calculator that lets me do a log of 1 plus 0.09 divided by 12. And I need to be able to put this into my calculator. The way we find exponents is by using logs. So I know I have to use a log. I'm actually going to write that note right up here. If you don't have that written down somewhere, it's going to be really important. To find exponents, we use logs. All right. A log is an operation. Just like addition is an operation. If I add 5 to one side, what do I have to do? Add 5 to the other side. If I multiply one side by 15, what do I have to do? Multiply the other side by 15. Multiplying is an operation, and then I do it with a number. I multiply 15 to something. Logs, with their bases, work the same way. But I only have 2 buttons for logs on my calculator. What are those 2 buttons? Common log and natural log. We have common log, which is base 10. And we have natural log, which is base E. It doesn't matter which one I pick, just like I can add 5 to one side and add 5 to the other, and it's the same equation. Or I can subtract 13 from one side and subtract 13 from the other, and it's the same equation. The base that I choose doesn't matter, as long as I do the same thing to both sides. Which log do you guys want to use here? It does not matter. There's no wrong answer. ln, all right, we can use ln. So if I do it to one side, natural log of 1.5 is equal to, I have to do it to the other side. So this has to be natural log of 1 plus 0.09 over 12 to the power of 12t. What can I do now that it's a log equation that I couldn't do before? I can use an expanding property. I'm going to bring this 12t where? Down in front of the log. So now it's not going to be an exponent anymore, which is really good because I'm trying to get it alone. Natural log of 1.5 is equal to 12t times the natural log of all this junk. All right, we're ready to pull out our calculators now. We're going to do these things one step at a time, because remember, calculators, when it comes to logs, are really dumb. We have to baby step it through what it needs to do. So we're going to practice putting this in a couple pieces. I want you to start off by putting in natural log of 1.5 into your calculator. Natural log of 1.5, and tell me what you get. 0.405. Do not round it. Leave it all on your calculator. Okay? We're trying to get t all alone. Who's over on the right-hand side with t? What'd you say? ln. It's ln of all that jazz, right? So to get rid of it, I have to divide by that. If you do it to one side, do it to the other side. That's going to cancel out. So on your calculator, still with that whole big long messy decimal up, I want you to type the division key. And ln. And what are we typing inside the parentheses with the ln?
1 plus 0.09 divided by 12.
Yep. 1 plus 0.09 divided by 12. Remember to close your parentheses. And I'm going to write this down over here. What's it giving you on your calculator screen when you do that?
54.264.
54.264, and then there's a whole bunch of other decimals. That's equal to what? We canceled out the natural log of all this jazz. What's still over here? 12t is still there. How do I get the t all by itself now? Divide both sides by 12. So I'm doing 54.264 divided by 12. Sorry, dear. And we get that t is right about what? 4.52. What kind of units should we put on that? Years. Remember, our question was how long, and investments are usually not just a couple days, a couple weeks, or a couple months. They do this long term, so we measure our time in years. All right. We'll practice another one of these tomorrow, okay? Because I know these are long, drawn-out problems, but does it feel a little bit more like you know what steps to walk through than yesterday when we did it the first time? The more practice that we get with it, the more it's going to make sense. I do want to go in your books right now, though, to page 154. We're going to keep practicing solving these log problems. Page 154. Stick with me here. Test is when, by the way? Friday. You guys are going to get a cheat sheet. It's just one side this time. I'll pass out to you the sheet that you're allowed to use because we're going to try to keep it consistent. Everybody in here is going to get the same color piece of paper, but then you can put on it whatever you want. All right? So I'll pass that out to you tomorrow so you can begin putting that together. One of the things that I want to make sure to point out, though, this should be really important when we're looking for an exponent or part of an exponent. Like right here, what I want to find is x, and x is part of my power. I know I'm going to have to use what to find that? Logs. Use logs to find exponents. We'll figure out what log first, or in just a little bit. Let me write down order of operations. What is order of operations? Yes, PEMDAS, P-E-M-D-A-S. Anytime we are solving for something or isolating, we go backwards through the order of operations. Where is exponents in this order of operations? Almost. Yeah, second to last, right? Here is where I'm allowed to use logs. and nowhere before there. So I need to identify my base, the thing with a power on it. On number 1, what is the thing with a power on it? 10. This is my base. This is what I have to isolate. So who's got to go? 5. What's happening between the 5 and the 10? Addition. How do I make that cancel? How do I undo that? With subtraction. So we're going to subtract 5 from both sides. What's 32 minus 5? 27. Have I isolated my base? Over on the left-hand side, do I just have one number that's written full size and any other numbers over there are part of the exponent? Yes. So I don't have any multiplication or division over here with my base. I can skip that step because I don't have it. So now I'm allowed to use logs. Which of the buttons on my calculator would help me? ln or common log. What's our base here? 10. So I'd want to use my common log, right? I'm going to use my common log. I could write my triangle at this point, but I'm going to try to also mimic the pattern that we were using before. You're welcome to write this down with a triangle. I'm going to write it very slightly differently just so that we can see a pattern happening here. Do you remember how on the last problem, once I had it written as a log, I could use my expanding property and I could bring that power down to the front? So I have negative 4x that's getting multiplied to the common log of 10. What's the base on the common log? 10. So 10 to what power gives me 10? 1. This whole thing right here simplifies to the number 1. So I have negative 4x times 1. Yep, is equal to log of 27. So that's just negative 4x. Equals the log of 27. How do I get x all by itself? Divide both sides by negative 4. If you did this with a triangle, you'd get the exact same final answer. You'd still be doing log of 27 divided by negative 4. What do you get when you put that into your calculator? Does it come out to be a positive number or a negative number? Negative. Big number or small number? Small. Negative 0 point something. After the decimal point, I want 3 numbers. Yes, ma'am. So let's see. Okay. So you have the negative as part of the log. Notice the log is in my numerator. I have to close my parentheses around this before I do the divide by negative 4. Great question. If you got an error on your calculator, make sure you're closing the parentheses after the 27. Yes, just like that. So negative 0.358. I'm writing down 4 numbers just so we can double check it. I only need you guys to give me 3. But I'm going to write down more digits as we're working these problems together. Talk me through number 2. Ernesto, what's the first thing I would want to do on number 2?
Get rid of the 12.
Get rid of the 12. What operation will let me get rid of the 12? Addition, because right now it's minus 12, so I'm going to add 12 to both sides. So I have e to the power of 3x plus 2 equals what? 26. Do I have my base isolated? Yes. The only thing on the side where x is one big number, in this case it's e, and everything else is part of the power. That's how I know my base is isolated. So now I'm allowed to use logs. I know I'm going to have to put this into my calculator, so I had to pick one of the buttons on my calculator. I have common log or natural log. Which one? Natural log. Why? Because it's a base of e. All right. So if I take a natural log of both sides, again, you can do this with the triangle, but I'm trying to repeat that pattern that's kind of new to us right now. Once I take a natural log of both sides, what am I allowed to do now with this exponent that I wasn't allowed to do in the step before? Move it to the front. I'm allowed to bring it down here. 3x plus 2. Natural log of e. This is e to what power equals e? 1. So this whole thing right here is just equal to 1. It's equal to the natural log of 26. When I multiply something by 1, it doesn't change at all. Remember, 26 is the argument, so I have to keep closing those parentheses after the 26 so it doesn't throw anything else off. I can start typing things in my calculator right now if I want to. I need to put the natural log of 26 into my calculator. I need to leave the whole thing up. What would I then do as I work to get x all by itself? Minus 2. So after you do natural log of 26 on your calculator, leaving all those decimals up, then you're going to minus 2 from it. And last but not least, you're going to do what? Divide both sides by 3. And you can absolutely, and I encourage you to hit enter in between these steps. Just don't erase that decimal on your screen. Big number or small number? Small starts with what? I got 0.419, absolutely. So natural log of 26, hit enter. Then minus 2, hit enter. Then divide by 3. Yes, sir. Instead of what?
Instead of how you did it previously with the common log.
So this time we chose ln because we had a base of e. And I know that the natural log of e is going to simplify to 1. So that meant less work. But over here we had a base of 10. That's the base on the common log. So a common log of 10 had the same thing happen where that reduced down to a 1.
You see how it's -4?
Mm-hmm.
Oh, never mind.
You got it? Okay. Let's look down at number 3. You guys are doing great with this, by the way. Look down at number 3. What's my base? 18 is my base. Is it isolated? How do I get it alone? Divide both sides by 2. So I have 18 to the power of negative 5v equals 31. Is my base isolated now? So now I'm allowed to use logs to help me unlock those exponents. Common log or natural log. Which one do you guys want to use? Common log. Does it matter this time? Why not? It's not a base of 10. It's not a base of e. So here it doesn't matter which one I pick. But you guys told me common log, so we're going to go with common log. So common log of 18 to the power of negative 5v equals common log of 31. Only because it's logged now. What am I allowed to do? Bring the exponent down. That does not work unless it's been logged. All right. Can I start putting stuff in my calculator? You can. Put this in your calculator. I'm not going to get a final answer from this, but I can do common log of 31 in my calculator, and I can hit enter. We're not rounding anything. You want to leave all those decimals up on your screen. But guys, I need you to practice putting this in your calculator with me. Log of 31. And after you have an answer for the log of 31 up on your calculator screen, we're going to divide that by something. What's over there with v that I want to get rid of? Negative 5. So take your log of 31 and divide it by negative 5. I need every single number that's on the screen because we're not allowed to round it. Don't erase it off your screen, but I do want to write down what we have. Negative 0.298272,339. Don't erase it off your screen. I'm only writing it down just so we can make sure that we have the same thing. Leave all that up on your screen because v is still not alone yet, right? What do I still need to do to get it alone? Divide both sides by log of 18. Now I have v all alone. I know it's a negative number, and I know it's pretty small. Negative 0. What?
237.
237, or if you rounded that to 238, that's okay. We doing all right? Cool. Let's keep rolling. Number 4. What's my base? 16. Is it isolated? How do I get it isolated? Subtract 1 from both sides. So I have 16 to the negative 5p equals what? 4. Huh. I think something interesting just happened here. Do you guys see this base of 16? And this 4 right here? 4 to what power gives me 16? Yeah. 4 squared equals 16, right? So I'm actually going to replace this 16 with a 4 squared here. Does anybody remember our rules for when we take a power to a power? What do we do with those two things? Starts with an M. Multiply. So this is 4 to the power of 2 times negative 5p equals 4, or 4 to the negative 10p equals 4. exponent is on this 4 right here? A 1. Question. If I said 4 times negative 10p equals 4 times 1, what would you know about these two things? They'd have to be the same because the 4's are going to cancel, right? Same exact thing happens here. These 4's are the same, so I can ignore them, and I can just say negative 10p would have to be equal to 1. How do I get the p all by itself now? Divide both sides by negative 10. And so p is negative 1 over 10, or I could write that as the decimal, negative 0.1. Well, that's kind of cool. I didn't have to pull out logs for that one. You guys okay if we look at another one that's kind of like that, where I can skip using logs altogether? All right, let's look down at the bottom of the page. I'm going to number 7. I'm skipping number 5, and I'm going down to number 7. What's my base? 5. And then over here I have 625. Does anybody know 5 to what power gives me 625? Try some things on your calculator if you don't know. 5 to the 4th power? Yeah, equals 625. So I'm going to write this 625 as 5 to the 4th power. What do you notice about those two bases now? They're the same, so they're going to cancel. Negative x is equal to 4, which means x has to be what? Negative 1. Or sorry, negative 4, not negative 1. X equals negative 4. When I can make those bases the same, they're going to cancel out, and then my problem gets a whole lot easier. Can I try the same kind of thing with number 8? Yeah, I'm just looking at the bottoms right now. 9 to what power gives me 81? 2. 9 squared equals 81. So 1 over 9, if I square it, that gives me 1 squared over 9 squared. That gives me 1 over 81, right? So I'm going to rewrite this guy right here as 1 over 9 squared. So what is x? 2. My bases are the same, so x is 2. I do realize the warning bell just went off, but flip the page real quick. Look at number 9. What do you notice about that one? Bases are already the same, so what can I do right from the beginning? Cross them out. So I have x plus 1 equals 2x minus 3. Do we know how to solve that? Yeah, we do. I'm going to subtract x from both sides. I get 1 equals x minus 3. And then I add 3 to both sides. So x is what? 4. Last one. We'll keep practicing with this tomorrow, but I want to look at one more. Number 10. What are my bases? 4 and 2. Which one's smaller? 2 to what power gives me 4? 2 squared gives me 4. So I'm going to rewrite this one as 2 squared, but then it still has a power of x on it. When I have a power raised to a power, what do I do with those? Multiply them. So this is 2 to the power of 2x equals 2 to the x plus 4. What can I do now? cross out the bases. 2x equals x plus 4. So what is x? X equals 4. Awesome. We're going to do just a couple more like this tomorrow, and I'm going to give you your reviews and your cheat sheets. After we do the bell work and we practice just a few of these, you guys will have the rest of the class period to work on your reviews and work on making your cheat sheets, and then we'll spend Thursday in a very similar fashion, except I'll take requests for things you guys want to see. All right? And we will especially talk about things that I think are really important to put on your cheat sheet, either examples or writing down words of how you know what to do and when. Very, very nice work. You guys, I am super proud of you. This is, if not the most difficult part of Algebra 2, it's the second most difficult. You guys are hanging with me, and I'm hearing a lot of really good feedback. If you still feel confused about it, that doesn't mean you're not getting any of it. This is hard. It took me a long, long time to understand logs. Like, I was almost done with college before I understood logs. I could make them work because I could just repeat what my teacher did, but I didn't understand what I was doing or why. If that's how you feel about it right now, you're starting to get it. It's hard stuff, and I'm very proud of you.